In this video, we will be solving absolute value equations. So before we jump into solving absolute value equations, let's take a look and remind ourselves of what an absolute value function actually is. The absolute value of a number is its distance from 0 on the number line. So when we're talking about absolute value, we're talking about its distance from 0. So we're going to talk about a few examples later on, but remember, it represents a distance. So if we think about distances, distances are always positive. You wouldn't ever say you ran -2 miles. That's silly. You wouldn't say that. You would just say you ran 2 miles. Direction doesn't matter. So it's the same thing here. Since it is a distance, it cannot be negative. And this means that the result of an absolute value, what it is equal to, cannot be a negative number. And then it uses the vertical line symbols to represent the absolute value function. So just to remind you of how the absolute value function works is any number can go into an absolute value. It can be inside. But what the absolute value function does is it finds that number's distance from 0. So in this case, the absolute value of 5 is just plain 5 because it is 5 units from 0. Here, notice a negative number can go inside, but the absolute value of -3, we're looking at distance from 0, and so that will also just be plain +3. So notice that any number can go into an absolute value, but it always spits out a positive number because it is always finding distance from 0. So let's look at the simplest equation we can have with an absolute value. So in this problem, we're trying to find what x could possibly be so that when that number is placed inside the absolute values, it equals a +6. And most students are able to very clearly state, well, x could be +6, which is true. But if we sit down and we think about a number line, 1, 2, 3, 4, 5, 6, +6 is not the only number that is 6 units from 0. So this question is asking essentially, what can x equal on the inside here so that it is 6 units from 0? And so there are two options here. Yes, +6 is an answer, but 1, 2, 3, 4, 5, -6 is also an answer because the absolute value of -6 is equal to 6 and the absolute value of 6 is 6. So for absolute value equations, oftentimes we have two answers because there are two possible numbers that can have that distance away from 0. So we need to be very, very careful as we solve these equations, as there could be two answers that we're looking for instead. So now let's look at a slightly more challenging example. If you look here, we now have more than just x inside the absolute value. We have x minus 3. And typically, if we had an equation like x minus 3 equals 6, we would just add 3 to each side, and we would have x is equal to 9. However, now that we've added these absolute value bars in there, we're a little more stuck. The thing about absolute value bars is that they act kind of like prism bars here. Nothing can break in or out. So what that means is you can't distribute into an absolute value function, and you can't take anything out of them. So like right here where we would want to add the 3 to each side, we can't do that. Instead, we have to think about what could the middle of this absolute value function equal. And so we're really looking at, okay, we have something inside of an absolute value equals 6. And so we need to start thinking, okay, what could this inside piece here, what possible numbers could it equal in order to produce a value or a distance from 0 of 6? So if we start to think about that, and I start to look here, what I realize is that there are two numbers that have a distance from 0 of 6. So those two numbers are going to be 6 and -6. So what that's telling us is that this inside piece can either equal 6 or -6. So the way that we break down these prism bar walls of the absolute value is we take one bar and we take x minus 3 and we say, well, one option is that x minus 3 equals 6. If we can make this interior part equal 6 here, the absolute value of 6 will be 6. Then we can break down the other wall by taking x minus 3 and setting it equal to negative 6, because if this inside equals negative 6, we'll have absolute value of negative 6, which will also be 6. So we break down those prison walls by setting the middle equal to both possibilities, both numbers that are 6 units exactly from 0. So now we just need to solve. So here we have adding 3 to each side, so we find x equals 9 is one option. And then we add 3 to this side, and we find x equals negative 3 is another option. And if we look here, if we kind of go back and test these out, say we had 9 minus 3. Well, 9 minus 3 is 6. So we have absolute value of 6 equals 6. That's true. And if we test out this one here as well, we get absolute value of negative 6 equals 6, and that is also true. So we've found 2 possible answers here of x values that make this equation true. So let's take a look at another example. So here again, we're looking for what can the middle of this absolute value equal? We can't break in and we can't break out of an absolute value, so we have to think about what can the middle equal if the whole equation equals 4. And in this case, we're looking for 2 numbers that are 4 units exactly from 0, which are 4 and negative 4. So we can break down our walls by setting what's inside the absolute value equal to 4 and negative 4. Because if 2x plus 8 equals a positive 4, this interior will be positive 4, and it will be absolute value of 4 equals 4. And then if 2x plus 8 equals negative 4, this will also work because absolute value of negative 4 is equal to 4. So all we have to do at this point is solve. So we have 2x equals negative 4, divide by 2. So one option is x equals negative 2. And then here we have 2x is equal to negative 12, divide by 2. And we find negative 2 and negative 6 are our 2 answers. So next we're going to look at what we do when the absolute value, which you can see right here, is not alone. So you can see that it has a 2 next to it and a negative 4. And the thing is, we learned on the previous page that we can't distribute in. So the 2 here can't distribute in, and we can't subtract the 3 out because we can't break into absolute values. They are like prison bars. So instead, what we're going to do is we're going to solve for the absolute value alone to start with, which means we're going to essentially pretend that this absolute value and everything inside of it is one big variable that needs to be alone. A couple of things to note is you cannot take anything out of the absolute value, so that's talking about the 3. You can't subtract 3 on each side. And you also cannot distribute into the absolute value, so that's pertaining to this too. So what we're going to do is we're going to undo everything else around it instead. So we're going to start by adding 4 to each side. So we have 2, absolute value of x plus 3 is equal to 16. We then divide each side by 2, and we have x plus 3 is equal to 8. Now at this point, this is a regular absolute value that we need to solve. So all we have to do is think about what does this inside need to equal so that the distance from 0 is 8. And that's where we're going to use 8 and negative 8. So now we can break down our 2 prison walls by setting the middle, x plus 3 equal to 8, and x plus 3 equal to negative 8, because if this middle piece equals either of those numbers, the absolute value will equal 8. So we subtract 3, so we have x is equal to 5, and x is equal to negative 11. So here when I look at this problem, I can see there's a lot on the same side of the absolute value. So I'm going to start by taking the 6 and the negative 3 and undoing those so that I can get the absolute value alone. So we start by subtracting 6 on each side. So that equals 30. And then dividing everything by negative 3. So I have absolute value of 2x minus 4 is equal to negative 10. So our first step is always to get the absolute value alone. Now at this point, I need to look for what number has a distance from 0 of negative 10. And when I take a look at that, I become a little bit confused because I know that distances are always positive. And if I start to think about this, I'm thinking, well, the middle of this equation needs to have a distance from 0 of -10. But distances can only be positive. And as a result, if we end up with an absolute value all by itself, notice it's alone, and it equals a negative number. If an absolute value is alone and equals a negative number, that's something that isn't possible because absolute values only produce positive numbers as a result. And as a result, we can simply state here that there is no solution, or you can just write NS. There's no value for x that will make this equation true because an absolute value will only produce a positive and cannot produce a negative.